Welcome back. So today is part 2 of our radicals work that we've been doing. So yesterday we were just simplifying radicals and adding and subtracting them. Today we're going to be multiplying and dividing with our radicals. So we're starting out with multiplication. So the first example that I have for you here, again, these are coming straight from your assignment. So if you look at the part 2 assignment, this first one is number 1 on your worksheet. So we have the square root of 18 times the square root of 5. So if we're just taking two radicals, there's no whole numbers in front of them, anything like that. We're just multiplying those two radicals. We're just going to take 18 times 5, and that's all going to go underneath the radical sign because those are both square roots. Okay, if one of these was to the third and one of them was a square root, we couldn't do that. But as long as they're both the same, you're just going to multiply those two numbers together. And so then we get square root of 90. And then we're going to simplify that, just like what we were doing at the beginning of the part 1 video. So simplifying 90, we're trying to simplify this down into factors that are perfect squares. And I know one of those is 9. So I'm going to go 9 and 10. So square root of 9, square root of 10. And square root of 9 is 3. Square root of 10, I can't break down into any other perfect squares, so I'm going to leave that as square root of 10. So when multiplying those two together, my final answer would just be 3 square root of 10. Okay, so again, we just multiplied the two numbers together that were underneath the radical sign. We got square root of 90, and then we simplified like what we were doing in part 1. Okay, so this next example that we have, this is number 3 on your worksheet. So now we're going to take a radical times two different terms. Okay, so we're distributing this radical to what we have inside the parentheses. So in order to do that, we're going to take the square root of 6 times the 5. And I always put my whole numbers in front of my radicals. So it's 5 square root of 6 minus 2 square root of 3 times the square root of 6. Okay, so now for this one, you'll notice my square root of 3 and my square root of 6, both under the radical. Those are being multiplied, so that's just like what we were doing up here. So we're going to multiply those together. So 5 square root of 6 minus 2 square root of 18. Okay, now we're going to take that 18 and we're going to simplify, just like what we did up here with our 90. So this becomes 5 square root of 6 minus 2. This would be a 9 and a 2. Again, sorry about that. Again, the reason why we're doing the 9 is because it's a perfect square. All right, sorry about that. So the 9, so this becomes square root of 9 times square root of 2. And again, we made it the 9 because a 9 is a perfect square, and we're always looking for perfect squares. That is going to become 3. So 5 square root of 6 minus 2 times 3 times the square root of 2. We're going to combine the 2 and the 3. 5 square root of 6 minus 6 square root of 2. And that's actually as simple as we can go with that one. We can't multiply anymore. We can't simplify any farther because those have different radicals. One's a square root of 6, one's a square root of 2. So we cannot combine those. All right, so the next example I have for multiplication. So this one, now we have a binomial that's squared. Okay, so we're going to do similar to what we did up here with our distributive. So we've got square root of 7 minus square root of 17 times square root of 7 minus square root of 17. Okay, so just like what we were doing in the last chapter, you're going to take first times first. So that's square root of 7 squared, because it's square root of 7 times square root of 7. You don't necessarily have to have the parentheses there, but I'm going to go ahead and put those there. And then we're going to take outer times outer. So that's a negative square root of 7 times the square root of 17. Okay, we're multiplying those two together. And then inners minus square root of 7 times square root of 17. Again, I'm going to put parentheses around all of this. And then last times last plus, because we have a negative times a negative, square root of 17 squared. Okay, so now we're going to go back through and simplify as much as we can. A square root squared, those cancel each other out, so we're left with 7 minus, we've got two of them that look exactly the same, so 2 times square root 7 times our 17, we end up getting 119, and then plus, again, a square root is squared, so this is just 17. All right, so then from there, I can combine the 7 and the 17. So 7 and 17 would be 24 minus 2 square root of 119. And then that's going to be as far as we can simplify that one. Okay, so that's the multiplication piece. The next part is division. So I've got 4 examples with the division portion. We're going to start with number 11 on your worksheet. So looking at number 11, there's a couple different ways that you can go about dividing things. So I'm actually going to show you number 11 and then number 16 to show you the 2 different ways, and then we'll move on with these other examples. So the way that I typically do these is if I have square root of 80 over square root of 5, I'm going to try to simplify those 2 numbers so that I can cancel some things out. So square root of 80, I want a 5. So 5 times what would give me 80? So that would be like square root of 16 times the square root of 5. Those are factor pairs that make up 80 divided by the square root of 5. The reason why I was looking for something that had the square root of 5, like my denominator, is because if I have square root of 5 over square root of 5, I can cancel those out from top to bottom. Now all I'm left with is square root of 16. Okay? And we know that the square root of 16 is a perfect square, and it's 4. So then our final answer for this one is 4. Okay, so like I said, there are different ways to go about dividing. So the other method is what I'm going to show you over here. It's example 16 in your handout. So we have 2 over the square root of 5. Now I can't simplify 2 to get a square root of 5 so that they'll cancel out. Okay, so the other way to do this, because we don't want a square root in the denominator, is we're going to take 2 over square root of 5 times, if I take square root of 5 times the square root of 5, then my square roots will cancel out. So whatever I do to the bottom, I have to do to the top. Okay, so we're going to take our original problem, 2 over square root of 5 times square root of 5 over square root of 5. So on the bottom here, I'm left with 5. Okay, because square root of 5 squared just leaves me with 5. On the top, we're going to multiply those together and we get 2 square root of 5. Okay, you can leave it this way or you can change it to a decimal. So 2 over 5 would be 0.4 square root of 5. But please don't think that you need to change that to a decimal. You are fine leaving it as 2 square root of 5 over 5. Okay? All right, so those are the 2 different ways to go about dividing with our radicals. So like I said, this is the method that I tend to use the most. If I can't simplify, that's when I go to this method. Okay? All right, so then let's take a look here at number 13 on your worksheet. So with number 13, we've got 10 square root of 72 over 6 square root of 2. So again, I'm going to try to factor simplify this 72 so that I have a square root of 2. Okay, so I've got 10 square root, and if I take 72 divided by 2, I'm going to get 36. So that would be 36 and 2. That's the same thing as the 72. Then on the bottom, I'm going to leave that as 6 square root of 2. Okay, so then from here, I'm going to simplify my 36. This becomes 6. So I have 10 times 6 times square root of 2 over 6 times square root of 2. Okay, so it makes it really nice because now I can start canceling things out from the top to the bottom. Square root of 2 with a square root of 2. A 6 cancels with a 6. So I'm left with 10 as my final answer. Okay, let's do one more of these. So this one looks a little bit different. So we've got a square root of 75 over 5 square root of 16. This is number 15 in your packet. So again, I am going to try to break this down into pieces that are easier to work with. So the first thing I want to do is when I look at that square root of 16, I know that that's a perfect square. So square root of 75 over, this is 5 times square root of 16 is the same thing as 4. So that's 5 times 4. So I've already simplified a little bit. The next thing I'm going to do is I'm going to look at that square root of 75 and say, okay, are there any perfect squares that are factor pairs of 75? Well, I know that there's one. 25 is a perfect square. 25 times 3 would give me 75. So that would be square root of 25, square root of 3, over 5 times 4 is 20. So square root of 25 becomes 5. And then the square root of 3 is still there. And actually, we could have left this 20 as 5 times 4. You could have left it that way as well. Because then at this next step, so we have 5 times the square root of 3 divided by 5 times 4. And then again, we're going to cross out things top and bottom that are in common. So I'm left with square root of 3 over 4. Okay, and that's as far as you would go with that one because you don't have a radical in the bottom. You do have one in the top, which is fine. So we would just stop there. You could also say that this is 1/4 square root of 3 or 0.25 square root of 3. Whichever one of those you prefer is fine. Like I said, you're more than welcome to leave it this way. Okay. All right, so that's all the examples that I have for you today. So that is part 2 of our radicals work. If you have any questions, just let me know. Otherwise, I'll see you in class. Have a great day. Bye.